Now once the reaction is balanced and we see the reaction stoichiometry, okay, this will provide us with the relative amounts of moles of each substances involved. So from this specific reaction, combustion of octane, we know that 2 moles of octane reacts with 25 moles of oxygen to produce 16 moles of carbon dioxide and 18 moles of water vapor, right? Why or how are these moles, how are these numbers, the moles numbers, how are these useful? First of all, these numbers, when you put them in the reaction, these numbers are known as coefficients. So if the question is, what is the stoichiometric coefficient of carbon dioxide in this balanced equation? The answer is 16. What is the coefficient of oxygen in the balanced equation? 25. So what are these coefficients going to tell us? For example, if the question was, how many moles of oxygen is needed to produce 35 moles of carbon dioxide. So your goal is to make 35 moles of carbon dioxide. So 35 moles of carbon dioxide is your goal. You know from the balanced chemical equation that 16 moles of carbon dioxide are produced when 25 moles of oxygen react. So to produce 35 moles of carbon dioxide, how many moles of oxygen do you need? So moles of carbon dioxide and moles of carbon dioxide will get cancelled. And your answer is 35 times 25 divided by 16, which would be 54, roughly 55, I would say 54, 55, so 54.6 moles of carbon dioxide. Since we have two significant figures, I will say 55 moles of oxygen will be required. So these numbers, these coefficients will be useful to make such calculations, to perform such calculations, so you will know how much of reactant that you could use. On the other hand, given the amount of reactant, you will also be able to calculate the amount of product. Try to understand the concept and we will do more problems in class.